Recording started.
Okay, Math8 students, this is going to be our whiteboard recording for the review session for this week for our upcoming test. So we're just going to get started with some stuff here. Guys, we're going to get into, at this point, stuff dealing with square numbers. And so when we talk about a number that's a square, another way we might describe it is a perfect square. So I've got some diagrams here that show a number that is a square of a whole number. That's what a perfect square is. So it can be represented by arranging objects in a square. So you can see here, guys, that the reason why the number 4 is a perfect square is because we can arrange it into a square made up of 2 by 2, right? Same thing with the number 9, which is 3 by 3, and the number 16. So that's why those numbers are called perfect squares, or sometimes we just call them squares, okay? And we'll see later on how squares and square roots relate to one another. But you guys remember seeing multiplication tables, of course, over the years, right? They look kind of like this. The cool thing is that, excuse me, that you can actually, if you color in all the diagonals on a multiplication table, that will actually give you all the squares, or perfect squares. So I don't know if you guys knew that before. It's kind of cool, isn't it? So that's a really quick way, you know, if you do have a multiplication table, of finding what they are. But of course, you do want to memorize them as well, eh? So you know what they are. But I just thought that was kind of neat. Okay, so we'll go on to the next page here. And so this is just showing how we get the squares. So of course, we multiply 1 by 1, and we get the answer 1. So 1 is a square. All the red numbers here are the squares, right? And so 2 times 2 equals 4, you know, and so on, right? And if you go on the next screen, you can see that I've done it all the way up to 15, or at least this PowerPoint thing that I got here did it all the way up to 15. Okay, so it's good to memorize them up to, I mean, you guys have probably memorized your times tables in the past, but if there's any you're rusty on, you know, it's good to just kind of review them a bit, eh? Okay. So just review those ones in red so you know them. Just because, you know, if you know them really well, then you can just answer questions bang, 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 you know, like really quickly, eh? Okay, so we're going to do our first question here, guys. I'm going to be asking you guys some questions in blue. And so if you guys can just give me some answers for these, I want you to avoid using your calculator right now if you can, okay? So which of these questions, or sorry, which of these numbers do you guys think are perfect squares or square numbers? Do you want to type out the ones that you think are squares, and we'll see if we can get them all? And as you guys do, as you guys tell me them, I'll just underline them on the screen. Okay, so 16, 49, good. Any others? Okay, so I see 64, and let's see, did we miss any? There's one that we missed. Can you guys see the one that we missed? 36. Good stuff. Right on. Okay, so it looks to me like you guys have a pretty good handle on what squares are. So that's the first question there. And I put the answers here, but that's probably pretty basic for you guys because you knew the answer, right? So here's the answer. And we'll go on to the next question then. So here's a question, guys, just to think about. And if you're going to explain this to someone else, you're going to explain the concept of a perfect square, how would you explain in a sentence or two how you know that a number is a perfect square? What would you say? You know, let's say you met some alien from another planet or whatever, and you said, hey, I want to explain what a perfect square is. What would you write? Okay, and what are we doing with those two numbers? Okay, so you multiply a number by itself. Okay, so you guys both have part of the idea, and you've got some good ideas that are part of the definition there. One thing I would say is that it's a whole number that's multiplied by itself to produce another number, right? So if we wrote, when we multiply the same whole number by itself, we get a perfect square. Okay, so does that make sense, guys? It's got to be a whole number, right? Because if we multiply like 2.4 times 2.4, then we won't get a perfect square. Okay? So I'm just going to check my email to see whether... Okay, so it looks like someone is trying to get on, but they're not able to log into the session, so we'll just send them the recording then. That happens sometimes, eh? Okay, so we got the idea of what a perfect square is. We go on to the next screen. So I'll just read some of the stuff here. So one property of a perfect square is it can be represented by a square array. All an array means is a bunch of squares in kind of a grid like this, okay? So in this grid here, each small square has a side length of 1 centimeter. The large square has a side length of 4 centimeters. Okay? So 4 times 4 is 16. So 16 here is the square number. All right. So remember this, guys, that since 4 times 4 is equal to 16, we can write 4 squared equals 16. So that's what this means right here. So if I were to write this in English instead of in math, I would say 4 squared equals 16. Or I could have written out the number 16 as a word. Okay? So again, the exponent 2 is telling us we multiply the 4 by itself 2 times. And again, some of the stuff's again probably pretty basic for you guys, but if we continue the trend, 4 to the exponent 3 is 4 multiplied by itself 3 times. And 4 to the exponent 4 is 4 multiplied by itself 4 times. Okay, so that's just review, right? Okay, so here's a few questions for you guys. What does 5 squared equal? Okay, 25, good stuff. So if you're going to write 5 squared as a power, how would you write it? Now, if you want to write it when you're typing it in, what I do is when I write exponents, I write them like this. You know that little hat there? If you're ever asking me questions on an email, that little hat means there's an exponent coming after it. So it's 6 to the exponent 7. So how would you guys write the number that's in 3a, which is in words basically? How would you write that in numbers using that little hat symbol? Okay, 5 squared, good stuff. And then if we go on to 5 cubed, do you know how much that equals? If you want, you can use your calculator for this one. You might not need to. $125, that's right, because it's 5 times 5 is 25, and then times another 5, that's going to give us 125. Good stuff. All right, so let's go to the next screen. Here's a question, and this is kind of made to be a bit of a thinking question. It's not one that has necessarily just one right answer. Okay, so explain the difference between 2 to the power 4 and 4 to the power 2. What would you say if you were going to explain the difference between those two? What kind of things would you say? This might be a little bit trickier in a certain way just because it seems like it's more open-ended. Any ideas though? Okay. Well, one thing you could say, I see Chantel's typing something out. Did you have any ideas, Chantel? Okay. Well, one thing you could say is you could say that 2 to the 4 equals 16, right? Because it's 2 times 2, which is 4, times another 2 times 2. And 4 squared, I didn't choose a very good example here, did I? Because 2 to the 4 is actually equal to 2 4 squared. Sorry about that, guys. I'm going to change this question because I chose such a bad example without actually figuring it out. Not a good thing to do. Okay, what I should have done was, let's say, 2 to the 3 and 4 squared. Okay, so 2 to the 3 is going to be, it's going to have an answer of 8, okay, and 4 squared is going to be 16. So that's one way of explaining the difference. They have different amounts, right? Another thing you could say is that, you know, in this case, in the first question, the exponent is 3, and in the second question, the exponent is 2, and you could say that the bases are different. Okay, so there's a few different ways you could explain the difference between these two numbers. And again, it's just an open-ended question, just asking you to be able to think of differences between those two numbers, different ways of explaining them. So their amounts are different, and their bases are different, their exponents are different. Okay? All right, so we're going to just talk briefly about square roots. I thought this was kind of a cool picture. I don't know if this is actually anywhere in the world or if this is just kind of a joke thing, but I thought it was kind of cool. The speed limit here is the square root of 677. And I don't even know how much that is. I'll try it out right now and see what it is. 26 miles an hour. Okay, so yeah, that makes sense. You know, school zones are normally a little slower. But anyways, just thought I'd pop that up there. So we're going to talk about square roots now. So they're the opposites of squares, right? So if you look at here, square numbers, when you've got 4 times 4 equals 16, we said that 16 was a perfect square. And so the number 4 is a square root. So we said that 4 is the square root of 16, right? Okay, so the square root is the number you multiply by itself to get the other number. Okay, so when we say 4 equals the square root of 16 in math symbols, this is how you say it in English, right? And again, I know this is a review for you guys. Okay, so again, a number which, when multiplied by itself, gives you another number. So 5 is the square root of 25. So finding the square root of numbers that are not perfect squares involves a little bit more work. So we've already seen that finding the square root of perfect squares is pretty straightforward, right? Square root of 25 is 5. Square root of 81 is 9. But if you're trying to find the square root of a number that's not a perfect square, it involves more work. And sometimes when you're finding the square root of a perfect square, you want to calculate that number. So sometimes you're going to see questions where it says calculate. So if you see the word calculate or find, you're going to need to use your calculator. Okay? Other situations sometimes ask you to estimate the perfect square. And in that situation, I said here, use your other calculator. In other words, your brain. Okay? So we're just going to go over how you estimate the square roots of numbers that are not perfect square. Okay, so for instance, if you look at a number like the square root of 41, you don't get a nice even whole number, right? Like you do with the square root of 49, which is 7. Okay? So what you know is, since 6 times 6 is 36, and 7 times 7 is 49, because 41 is between 49 and 36, the square root of 41 has to be between 6 and 7. Okay? So we're just going to go over now exactly how you do that, estimating square roots. Okay, so first of all, well, before we go into estimating, we'll just talk about calculating square roots. So again, if you have a question that says, you know, find the square root of 82, all you need to press on your calculator is 82 and then the square root symbol. And on your calculator, the square root symbol might have an X underneath it. And if you do that, you should get 9.06. Okay, so if you've got a question that says calculate the square root, find the square root, that's what you have to do, is press the number like 82 and then press the square root symbol and you'll get the answer. Okay, so let's see if you guys can do that then for this one here. So question 5 says find the square root of 32. So I want you guys to tell me what that is. Okay, 5.7. So are you able to get the same answer, Chantel? Do you have your calculator handy there? Okay, we'll try that one later on. And sorry, I noticed you're typing. Okay, 5.6, so it should be 5.65, 656, so it's about 5.66, right? Okay, so that's how we do it on the calculator. And for the next question, if question 6 says, if a square-shaped yard has an area of 128 meters squared, what is the length of one side? So do you guys know how to do that question if you got a question like question 6 on the test? Yeah, that's right. The last one should be 5.7 because we round up the 6. Okay, so if we had question 6, would you guys be able to find the length of one side if this was kind of like a problem type question? That's right. Question 6 is kind of like question 5. It's just a word problem, right? So we're taking an area of 128 meters squared. You know, that's our area. And so we know that has to be something times something. So we have to take the square root of that 128, and that's going to give us our answer. So I'll just put 128 equals, and Karis told us it's, how much again? 11.3, right? Okay. So again, oops, I typed that in the box there. Okay, I'll type it on the whiteboard. Yeah, so again, similar question to question 5, just a word problem, right? Good stuff. Okay, so one thing I wanted to mention to you guys, because we are estimating, when we're estimating the square root of a perfect square, and that's what we're going to look at next, we need to show our work, because, you know, someone could say, okay, I'll just plug it into my calculator and I'll write down the answer. But you wouldn't be able to get full marks for that because, you know, that's too easy to do, right? If you're estimating, you have to actually show how you estimated it. Okay? So we'll go through that on the next page. So let's say we were going to estimate the square root of 27. And again, it's not a perfect square, so we can't find any whole number that multiplies to that amount. So, okay, so this here is just saying not all numbers are perfect squares. And it says to calculate the square root of a non-perfect square, we place the values of adjacent perfect squares. Okay, adjacent perfect squares, the word adjacent, it just means perfect squares that are side by side. Or not, they're not side by side. They're either above or below the one we're looking at. Okay? And then it says interpolate. Well, that's a big word, eh? Interpolate is just kind of find the information that's in between. Okay, and estimate to the nearest tenth. So we'll see how we do that. Okay, let's look at an example then. So if we're looking at the square root of 27, first we need to find the adjacent perfect square. So that basically means find the perfect square above and below this number 30. Okay, so we know that 25 is the first perfect square that we get below 30. 36 is the first perfect square we get above it. Okay, so then we look at what those numbers are as far as the square roots. Okay, so the square root of 25 is 5, and the square root of 36 is 6. But we want the square root of 27. Now you can see, looking at this here, that the square root of 27 is closer to 25 than to 36. So it's closer to the square root of 25, which is 5, than the square root of 36, which is 6. If this is kind of halfway in between, which is about 5.5, well, we're saying, well, it's going to be somewhere around 5.2. As long as your estimate is closer, considerably closer, because And the 27 is a lot closer to 25 than it is to 36. So that's why our estimate is 5.2. And as long as it's closer to the 5 than the 6, you'll probably get the right answer. Okay, so I just wrote that here. Since 27 is closer to 25 than 36, our answer is closer to the square root of 25, which is 5. Okay, so does that make sense, guys, how we estimate the square root of numbers? I'm going to take that as you guys understand. Okay, if you don't, we can go over it again, okay? Okay, so let's practice. Okay, and before we do, I just want to prove, since we took our estimate, which was 5.2, and we multiplied it by ourselves, we should get the original answer, or very close. And when we do, we get an answer of 27.04, which is really close to 27. So we knew our estimate was right. Okay, so you can do that to check your estimate. All right, so guys, let's try it for the square root of 51. Can you guys tell me what the perfect square is that's below 51 and the one that's above it? Okay, so 49 is the one that's below it. So I'm going to write 49. I'm going to write the square root of 49. And which is above it? The next one that's above it. Okay, square root of 64. And so what does the square root of 49 actually equal? Going to equal 7, right? And the square root of 64 is going to equal 8. Okay, so the square root of 51 has to be below and above. It has to be between 7 and 8. So what do you guys think? Is the square root of 51 going to be closer to 7 or 8? It's going to be closer to 7, right? Because the number 51 is only 2 more than the number 49, whereas it's 13 less than the number 64, right? Okay, so what would your estimate be for how much the square root of 51 would be? Seven point what? Okay, 7.2. Chantel's typing something as well. Okay, does 7.2 sound about right? So let's try it out. If we multiply 7.2 times itself, we get 51.84. Well, that's pretty close, isn't it? That's in the ballpark. So that sounds like a good estimate. Okay. So does that make sense to you, Chantel, how we got that? Okay. Well, so here's how we got it. We didn't know what the square root of 51 was, but we said we do know what the square root of 49 is. Again, 49 is the perfect square that's just below the square root of 51. And 64 is the next perfect square. Because again, we're looking at all the perfect squares. We know that 1 times 1 equals 1, 2 times 2 is 4. If we could write down all those perfect squares on a page, we would say that the one that comes below 51 is 49, and the one that comes right above it is 64. So does that make sense so far, how we chose 49 and 64? Okay, and so then what we needed to do was find out what the square root of 49 actually is, and we knew it was 7, because 7 times 7 is 49, and we knew that the next one above was 8, because 8 times 8 is 64. Then we compared the number 51 to 49 and 64. We said, what is it closer to? And we said it's definitely closer to 49, because 51 is just a little bit bigger than 49, whereas it's a lot smaller than 64. So for that reason, we made the estimate that we chose to be just a little bit bigger than 7. That's why we chose 7.2 instead of something like 7.8. If we were looking at, say, the square root of 59, then it might have been closer, like maybe something like 7.7. But because 49 is just a little bit less than 51, or rather 51 is just a little bit bigger than 49, our estimate for the square root of 51 is going to be just a little bit bigger than 7. So does that make sense why we chose something like 7.2? Okay, good. Good stuff. I'm sorry. Sorry guys, I got a cold. It's hanging on here. Okay, well let's check out square root of 30 then, and give that one a try. So for the square root of 30, what would the perfect square be that's below 30? What's the next perfect square below 30? Okay, 29. So is 29 a perfect square? Can we multiply a number times a number to get 29? It'd be 25, right? Okay. So the next perfect square is going to be 25, the next one below. So 25 equals 5, right? Okay, what's the next one that's going to be above? Above 30. Okay, 36, and the square root of 36 is going to be 6. Okay, so what do you guys think? Do you guys think that 30 is closer to 25 or 36? Okay, it's a little bit closer to 25, but just a bit, right? So would you say that it's pretty close to both? That's fair to say, right? So if the answer to the square root of 25 is 5 and square root of 36 is 6, our answer is probably going to be somewhere around 5.5. And if we multiply 5.5 times 5.5, we get 30.25. So again, that proves that the method works, right? Okay? So that's how we estimate perfect squares. Okay, so let's go on to the next section. We're just going to review, there were 3 different types of angles that we looked at. Okay, we looked at right angles, acute angles, and obtuse angles. So a right angle, again, is an angle that is 90 degrees. And we see those things all over the world, right? Everywhere, if we look around the house, you look at a table and it's got right angles. You look at a door, it's got right angles. A book has right angles. Those things are everywhere, right? Okay, acute angle. Now those things are less than 90 degrees. And I just wrote here, would you agree this angle is pretty cute? All right, just a joke there. All right, so an obtuse angle is an angle which is greater than 90 degrees. Okay, so we've looked at right angles are equal to 90 degrees, acute angles are less than 90, and obtuse are greater than 90. All right, so I'm just going to test your knowledge, guys, and see if you got it now, okay? So what I want you guys to do, it keeps cutting out. Okay, I think I might have leaned back a bit. Can you hear it okay now? Can you hear things okay right now, Chantel? What I might need to do is try to get rid of some files or something like that. Sometimes if you use the whiteboard a while, then there's these little mini files each time you use it, and sometimes you have to clear them out, and then it improves the sound a bit. But does it sound better now? I'll just make sure I don't lean back, because that could have been it as well. Sorry about the phone, guys. Okay, good stuff. Okay, so guys, what I want you to do is beside the word obtuse, right, and acute, I want you guys to tell me whether it's equal, less, or greater. So what do you think? Is an obtuse angle equal to 90 degrees, less than 90, or greater than 90? What do you think we should write in here beside obtuse? Okay. All right, so this one is actually bigger than, you could say, or greater than, right? Okay. So how about a right angle triangle? Do you think it's equal to 90 or less than 90? Okay. Equal to. And the acute one, I guess we're left with less than, right? Okay. So the acute should actually be less than, okay? Because if we look back on here, this is the acute one here. It's smaller than 90. Okay. So that's just a bit of a review. And what we're going to talk about now, guys, is the Pythagorean theory. Can you hear me a little better now, Chantel? Are you still having trouble? Okay, so I just put a little cartoon in here. I said you might be right, Pythagoras, but everyone's going to laugh if you call it a hypotenuse. Okay, so what's this business about a hypotenuse again and the Pythagorean formula? Okay, we're going to go over that just a second and look at those funny, I think they're Greek words maybe. Okay, so this is the Pythagorean theorem, which is, just think of the word theory or formula. So a guy named Pythagoras found an amazing fact about triangles. He found that if you had a triangle with the right angle, and we said before we can see those all over the place, right? So if it has 90 degrees and you made a square on each of the three sides, like we did here, then the biggest square had the exact same area as the other two squares put together. So in other words, this square, which is the biggest square, has the same amount of area as this square and this square. Okay? Remember, this is area, right? When we're multiplying length times width. This here is area. So this amount of area is equal to this amount of area plus this amount of area. Okay, so let's see how it actually works. So if we've got a triangle that has sides of 3, 4, and 5, this formula should work. And let's see what the formula looks like. Okay, so this formula says that if we square the biggest side in other words, we do 5 squared, that will equal to the other two sides squared and adding them together. Okay? So 5 squared equals 3 squared plus 4 squared. And when we take 5 squared, that actually equals 25. 4 squared is 16, 3 squared is 9. Do 9 plus 16 equals 25? Yes, they do. So it proves that the amount of area on the longest side is equal to the amount of area formed by the short side plus the other short side. Okay? So we call the longest side the hypotenuse. And another way of saying this formula is that c squared, which is the longest side, is equal to b squared plus a squared. Okay? So we'll see that written down here. So again, longest side equals short side plus longest side squared equals short side squared plus the other short side squared. Okay? So now let's see how we use that to figure out a problem. So again, that's the Pythagorean formula. A squared plus b squared equals c squared. Okay, now why is this formula useful? Well, if we know the length of two sides of any right-angled triangle, we can use this theory or this formula to find the third side. In other words, the missing side. Okay. So what we always want to do is, first of all, it helps to label a diagram. If we've got a problem, it helps to set up a diagram and then write this formula and then solve for the missing c. Okay, so we're going to use algebra to solve for the missing amounts. So let's look at an example of how to do that. Okay, so here's a problem where we have a missing hypotenuse. The longest side is missing, and we're calling the longest side c. We don't have to, but if we always do it that way, it kind of makes it easier. Okay, so our basic formula is that a squared plus b squared equals c squared. We don't know what c squared is, but we know that 5 is one of the sides, so it's going to be 5 squared plus 12 squared, right? Now we actually write what those amounts equal. 5 squared is 25, 12 squared is 144. So then we add those two amounts. So on the left side we get 169 equals c squared. But we don't want to find out what c squared is. We want just c, right? Well, how do we go from c squared to c? If we have c squared and we take the square root of c squared, taking the square root of something and squaring something are opposite. So if we have c squared, but now we take the square root of c squared, those two opposites give us just c, right? And we want to do the same thing to both sides of the equation. So we also now take the square root of 169, and we get 13. So that gives us c equals 13. And that kind of makes sense, right? When we look at our answer and we see that it's 13, if we would have got 7, we would have said, no, that doesn't make sense. Because c is our hypotenuse, and the hypotenuse is always the longest side, so we were expecting some number that was going to be larger than 5 or 12. Okay, so we're happy when we see that c is equal to 13. Okay, so that's how we got our answer. So if you need to solve for the hypotenuse, this here is exactly the steps that you would use to do it. Okay, so let's try this one. Let's see if you guys can solve for this hypotenuse. Okay, so tell me, guys, what you would do as the first step to solve this. If you're trying to solve for c, what would you do? Okay, so you would label it. Okay, and how would you set up your formula? You're going to take the info from the diagram. Okay, you're going to say equals 12, b equals 5. Good. And now how are you going to plug that into the Pythagorean formula? Could you show me what the first step of that would be? Okay, so we're going to write 12 squared plus 5 squared, those are the two shortest sides, are equal to c squared, which is the longest side. Okay, good stuff. So on the next page, I'm just going to continue with this solution. Okay, so we see, just as Karis told us, we're going to label A and B. And so here we've got the first step. That's the same thing we just did. And now all we do is we take 12 squared, and we're going to find out what it is. It equals 144. We find out that 5 squared is 25. And so that's going to equal c squared. Now we add those two amounts together. So 169 equals c squared. And it turns out we're actually going to get the same answer in this question as we did for the last one. So we just take the square root of both sides, and we get c equals 13. Okay? So I think we had different numbers, didn't we, in this one than the last one? Yeah. Well, wait a second. We had 5 and 12? Maybe we had the same ones. Okay. Looks like we had the same ones. I didn't even realize that. Sorry, guys. I meant to choose different answers, different numbers. Anyways. Okay. So we know how to do this. So here's another question, guys. Do you remember what an isosceles triangle is? Okay, an isosceles triangle is a triangle that has two angles equal to one another. Now, this angle that you can see here is a special kind of isosceles triangle because it's a right-angled isosceles triangle. So one of the angles is 90 degrees and the other two angles are equal. Okay, so let's say we had a question that says you've got a right-angled isosceles triangle, and if the question said that the hypotenuse in the triangle above was 7.07, and the question said how long are each of the other two side legs, okay, you can call the other two sides legs or you can call them sides. So how would you find this, guys, if you wanted to find the other two sides, given that the hypotenuse was 7.07? Okay, well, we're going to start off by saying that c squared, or longest side, is equal to a squared plus b squared, right? Just like we do any time we're using this formula. We know, in this situation, we know how much c squared is. We know that c is 7.07, so we're going to say 7.07 squared. Okay. Now, we could say that it's equal to a squared plus b squared, but because a and b are the same amount, right? In other words, the length of both legs are going to be the same amount. I'm sorry, guys. I'll just take the phone out of the room. Oh, I guess I got two phones in this room. Sorry about that, guys. Okay, so because of the fact that both of the other two sides are the same amount, in other words, A and B are the same amount, right? We can call them both A squared or both B squared, because that's going to allow us to solve this problem, okay? So it's like saying C squared equals A squared plus A squared, or B squared plus B squared. It doesn't really matter which you choose. Okay, so we're going to call it A squared. So now we have 7.07 squared is equal to 2A squared. Okay, we're going to see how that helps us to solve the problem. If we didn't do that, we wouldn't really be able to solve this problem. Okay, so now what we do is we take 7.07, we square it, and we're going to get 49.9. We basically are going to get 50. So we're just going to write 50. Okay? So 50 is equal to 2a squared. Okay. Now remember, we're after a, right? A is telling us what the length of either one of the other sides is. If we want to find a, what do you guys think we would do at this point in our solution to find a? Remember, we're solving an equation. Do you think that we would add, subtract, multiply, divide? If we want to get a, so remember we want to end up with just a on the right side of the equation. But what do we need to get rid of if we want to end up with just a? Okay, we're going to take the square root, but before we do, right now we have 2a squared, right? Remember, 2a squared is the same thing as 2 times a squared, okay? So we need to get rid of that 2 because we want to end up with just a squared in our next step, right? So what are we going to do to get rid of the 2 times? We're going to divide. That's right. And how much are we going to divide by? We're going to divide by 2. That's right. Because we've got a squared times 2, we want to get rid of that 2, so we do the opposite of times and we divide. Okay, so we're dividing both sides of the equation by 2 to get rid of that 2. And so now we're going to end up with 25 is equal to just a squared, right? Because the 2 on top, sorry, pressed the wrong button. 2 on top and the 2 on bottom cancel out. 2 over 2 is just 1, so we get rid of it, right? Okay, so we got 25 is equal to a squared. So how much is a equal to? If 25 is equal to a squared, it's like saying 25 is equal to some number squared, right? 25 is equal to 5 squared, right? So 5 is equal to a. Okay, so we're going to write 5 equals a. And remember, if we wanted to do it using the same math that we did before, we would take the square root of both sides of the equation. Remember, if we want to get rid of the squared, we take the square root of it, right? And we also need to take the square root of 25. And so that's how we're going to get 5 equals a. Okay? So I think that might be it, guys. Nope. We've got one more question. Okay, so this question is asking us to prove whether a triangle is a right triangle or not. So if I gave you guys 3 side lengths, say I gave you 3 numbers that were the side lengths of a triangle, would you guys be able to prove whether they were the sides of a right triangle? And if you could do it, how would you do it? Any thoughts? That's right, we're going to use the ABC thing, as Karis put it. Right? We're going to use the Pythagorean formula. So, we're going to use this here. A squared plus B squared equals C squared. Okay? So, if you had the numbers 3, 4, and 5, and the question said, state which of the following would be the sides of a right-angled triangle, what you'd need to do is to test whether 3 squared plus 4 squared equals 5 squared. Okay? So would you guys say that's true? Okay, because 3 squared is 9, 4 squared is 16, and 9 plus 16 equals 25, which is 5 squared. Okay, so the first one's right. Let's check out the next one. 2 squared plus 4 squared. Okay, 2 squared plus 4 squared is equal to 4.5 squared. Remember, we always want to make the number that's just by itself the largest number, right? So in this case, it's 4.5. Okay, so let's see if this one's right. Okay, 2 squared we know is going to be 4. 8 squared is going to be 16. And how much is 4.5 squared? Can anyone tell me? Okay, that's going to be... Oh, somebody's typing. Just give you a second. I'm looking for 4.5 squared. I'm thinking maybe what you did was found the square root of 4.5? Okay, so we're looking at 4.5 squared, so we're looking at 20.5. Okay, so in this situation here, we would say that 2 squared plus 4 squared, so 4 plus 16 is 20. That's the left side of the equation. Right side is 20.5. You know, in a way they're not equal, but it kind of looks like they're very close. If I was, you know, if I was doing it in a question on a test, I would try to make it closer than that, so that you could say for sure those two amounts are equal. They look really close to equal. You know, again, 20 is really close to 20.5. We can't say for sure they're equal. So again, I'd make it closer on a test. Let's try the next one. 5 squared plus 7 squared. Does that equal 9 squared? Okay. Well, 5 squared is going to be 25 plus 49. Is that going to equal 81? And the answer is going to be no, because we add together 25 and 49, that's going to give us 74. 74 does not equal 81. Okay, so C we can definitely say is not a right angle triangle. So we would say A for sure. B seems like it could possibly be, you know, it's close. The left side is almost equal to the right side. Okay, and C is definitely not right. Okay, so that's how, guys, that's how we would use the Pythagorean formula to state whether the three sides are the sides of a right angle triangle. So guys, we're done. And so what I just want to encourage you guys to do is to keep practicing these questions over and over again. All the blue questions that we did on this review, what I'll do as well, I'll send out the recording to you guys, and then you can practice all the blue questions just to make sure you can get them. And if you can get all those blue questions right, you'll have a lot of confidence that you can do well on the test. Okay? So if you do have any other questions as you're studying, just give me a shout. The test. Yeah, let's just check that out again, because I have a whole bunch of tests this week, and I can't remember for sure, but I'm pretty sure it's on Wednesday. I'll just check that out. I'm going to have to, looks like I got kicked off of school, so just give me a sec here. Yeah, Chantel says it's October 6th, and I'm almost positive it is. That's right, October 6th, which is Wednesday. Okay? So guys, thanks for your good participation in this whiteboard session, and I hope the test goes awesome for you guys on Wednesday. All right, well, I'll let you guys go. So thanks again for coming, and hope you guys have a great rest of the day. Take care, and God bless.